started. Today is the 25th. Today we're going to be calculating limits algebraically. Calculating limits algebraically. So what I'm going to do is, like I've said, I'm going to try to start doing, is making sure that I split up level 1, 2, and 3 problems so you know what is expected when we take an exit ticket or quiz, okay? We will have a quick exit ticket tomorrow. It's only going to be 6 problems. It's only going to be 6 problems, okay? It's going to be quick. Okay, sorry. So, like I said, I'm going to split these up into what level 1 looks like, and 2 and 3. But you can use all of these limit laws for all of them, okay? But I'm just trying to split up so you know what is expected at each level. All right, so we're going to talk about limits laws for level 1. Limit laws for level 1. I'm going to give you the name of the limit law, then I'm going to give you the law, and then give you a quick example of what it looks like. Okay. So the first limit law we have is the constant law. The constant law says that if we have a limit as x approaches a of some constant, it will just be that constant. Miss Santana, what is a constant again? Oh, great question. A constant is a number without a variable. Okay? So when we did way back all these years, y equals mx plus b, b was a constant. Okay? Because it doesn't have a variable. So, for example, if I have the limit as x approaches 6 of 172, this is a constant. It does not have a variable. The limit is 172. That is your answer. So, I'll just wait until you're done. I don't want to talk while you're writing. So I know that we've been doing limits graphically, and we're still going to be doing that, but we're trying to connect them. So what this looks like, you can write this down if you like. I'm going to put 2 graphs here. I'm going to put one graph for constant and one for the next one. So this is, make sure you know which graph it is. So if I have a coordinate plane, and this is going to be 172. And then this is 6. Does everybody have this down so I can zoom in? Does anybody need this stuff? Okay, let me zoom in so we can see what I'm doing, okay? So when we first started to do limits, remember I said that we're going to have to draw a line down where that x value is. And I need to come from the left side of the graph and the right side of the graph. And if they meet, if they have the same value, that is the limit. And the limit here is 172, okay? So that's what it looks like graphically and algebraically, okay? Does that help for those of you who didn't get the law? And it's okay if you don't, because this is new, okay? So I'm trying to connect the graphic the graphs and the laws, so you can see what I'm talking about. Okay. The next law, please stop me also if I'm going too fast, okay? The next law is the linear law. The linear law says that if we have the limit as x approaches a of x, then the limit is just a. Meaning, for example, if we have the limit as x approaches -7, who's ever next can go, of x, that is just going to be equal to -7. That's an x, just so you guys know. An x, an x, an x. Now, graphically, when we have y equals x, that means the x value and y value are going to be the same. So if I have y equals x here, oops, sorry, it's all equal. So if I have -7, let's say -7's here, and I draw the line, which means if I approach from the left, I get this value. I approach from the right, I get this value, and that value is -7. Okay? So this is graphically, and this is algebraically. This is what it looks graphically and what it looks algebraically. Okay, the next law that we're going to use is not really given to us in calculus, but I created it so that this way you can make sure to understand what's going on. This is still level 1. This is still part of the linear laws. It is the limit as x approaches a of mx plus b. And that's going to be equal to m times a plus b. I'll wait until you write that down to ask this next question. Does anybody see what I did to get the limit? What is the difference between the left side and the right side? Say that one more time. Very good. What mathematical vocabulary is that? Replacing. Starts with an S. Substitution. So I used substitution to substitute in the A for the X. Okay? That's all we're doing, is we're substituting in A for the X. Which means that, going back here, I'm substituting the A into the X. And that's how I get -7. There's no X here, which is why it's just the constant. Okay? We're basically just substituting in to find the limit. You look great. You don't need to look in the mirror. So for example, if I have the limit as x approaches 2 of, I don't know, 6 minus 7x, that's just going to be, or not to be, 6 minus 7 times 2, which is -14 plus 6 is -8. Okay? So that is my limit of that. When you're done writing that down, take out the notes sheet, example sheet, the example sheet. We're going to do level 1 examples before we move on to level 2 and 3. Okay, we're going to do level 1 examples before we move on to level 2 and 3. Seniors, it is up to you where you want to write this, because when we get further on to the more detailed examples, you might have room on this paper. Okay, so write it in your notes. I'm suggesting you write it in your notes, but if you want to write it on this paper, write it on this paper. Okay? All right, are we ready? Okay, I'm going to write it on here. What? You going to go to the bathroom? Okay. All right, so we're on level 1 examples. Hold on, got to pull up my examples so I can see where we're at. Okay. So our first example, the limit as x approaches 6 of 7. What is going to be that limit? 7. This is 7. Oh. Mr. Escobar. Yeah. We gotta send a ticket in for her.
He says he did, but it's not working.
Okay. I'll escalate. Hopefully I can. Seniors, a lot of students, I don't know how many times I've taught this and said it a million times. At least one of you will put the answer as 6. No, it is not 6. You are looking at the constant, okay? You're not looking at what the x value is. Your limit is the constant for this example, okay? Your limit is the constant, not your x value, your constant. Number 2, the limit as x approaches 2 of x. This is the linear rule. What is this limit going to be? Yes, 2. I heard the whispering of 2. Yes, 2. Okay, these are all level 1. These are all attainable. That's how we make level 1s. We make them so that they're attainable, and there's no reason you should be getting a D in this class. Actually, there's no reason you shouldn't be getting at least a B in this class. But some of you are not. Shade, yes. All the shade. Any questions on 1 or 2? Are we sure? Okay. Number 3. We have the limit as x approaches negative 6 of 9 minus 8x. So what we're going to do is we're going to substitute in the negative 6 for the x. That's going to be 9 minus 8 times negative 6. And that's going to be, or not to be, 57. Can. What happened? You didn't go? Oh. Can somebody double check my math? I'm pretty sure it's 57. Thank you. Okay? Questions? You sure? No? Yes? No? 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 Are we awake? Good? Mm-hmm. All right. So let's now move on to level 2 and 3 laws. Level 2 and 3. Okay. All right. So these are level 2 and 3 limit laws. All right, we have 5 different laws. So I'm going to give you the name, the law, and an example, okay? The name, the law, and the example. No example, just the name and the law. We'll do examples in a second, okay? So we do have to have some stipulations. We have to make sure that the limits of the functions exist, because you cannot use these laws unless they exist. So what we're going to say is the limit as x approaches a of f of x is equal to limit 1. And the limit as x approaches a of g of x is equal to limit 2. So we have to make sure that we're stipulating these, because they have to exist in order for us to do them. They have to exist. So these two things are limits that exist. And not only that, not only do the limits have to exist, the a values that they are approaching have to be the same value. Can you see that color? Okay. They have to be the same value. You cannot have two different values. If you have two different values, you cannot find that limit. So if I accidentally put them on different values on the quiz, please let me know, or the exit ticket, because I just made a mistake, okay? Maybe. So, one last time. The limits have to exist, and they have to approach the same a value. They have to exist, and they have to approach the same a value. No. Okay. So, limit 1 is the addition rule. The addition rule says if I have the limit as x approaches a of f of x plus g of x, then I can find those limits separately and add them together. I can find the limits separately and add them together. This will come in handy a lot. When you get to level 3 and 4, this is going to come in handy. Okay, splitting them up makes it easier. So it's going to be the limit as x approaches a of f of x plus the limit as x approaches a of g of x. Oops, sorry. So in this thing, we've already said that the limit of f of x is L1. So the final answer is going to be L1. And we said that the limit of g of x is L2. So the final answer is just going to be L1 plus L2. The first limit plus the second limit. Okay? Am I going too fast? Nobody's saying anything, so I'm just going to keep going. Yeah. I'm going to keep going the same speed. Okay. B is the subtraction rule or law. So instead of addition between the two functions, what are we going to have between the two functions? Yes, subtraction. Why don't we just talk louder? So if we have the limit as x approaches a of f of x plus g of x. Oh, not plus. My bad. What should be there? Minus. Then we can subtract the limits. Again, the limits have to exist. And they have to approach the same number. And that's going to be equal to limit 1 minus limit 2. limit 2 subtracted from limit 1. Order matters here. Order matters because having 4 minus 2 is not the same as 2 minus 4. Crystal. Okay. C. We have 3 more laws. Multiplication. What do we think we're going to do to them? Yes, spell that word. Multiplication. What do you think we're going to do to the 2 functions? Multiply. So f of x times g of x. We can split them up. And do the limit as x approaches a of f of x, bless you, times the limit as x approaches a of g of x, which will be equal to the limit 1 times limit 2. Crystal. Second to last rule. Am I going too fast? Okay. I'll slow down a little bit. Thanks. Alright, second to last one is division rule. What do you think we're going to do to the limits? Divide. I should have just made you come up with the division rule. The limit as x approaches a of f of x times g of x. Nope. Sorry, my bad. I was going too fast for my own good. Divided by g of x. It will be equal to the limit as x approaches a of f of x in the numerator over g of x in the denominator. Which means that all we're going to do is divide the 2 limits. Alright. And then last but not least is the radical law. Does anybody know what a radical is in math? Does anybody know? Radical is like a square root or a cubed root. That's a root, okay? The radical law says that if we have the limit as x approaches a of the nth root of f of x, n is the root of the function. For example, we have cubed fourth, and squared, but squared is understood. Meaning, am I off screen? Meaning that this is the square root. This has an understood 2. So all that means is I can take the nth root of the limit and that's just going to be the nth root of your limit. Okay. When you're done writing those down, take out your example sheet, but keep your notes out because we're going to be writing the examples in our notes. We're going to hopefully get through level 2. If we don't get through level 3, we'll do that tomorrow. Okay? Crystal, go get water. Yeah, it's an n. Because it could be any number. Huh? My what? Oh, yeah, sorry. Right? Sure? Okay. So let's look at, no, we have not done level 1 examples, right? All right. Let's look at level 2. The difference between level 2 and level 3, where did my examples go? So the difference between level 2 is that here, you don't have to calculate the actual limits. They give you the limits, okay? You don't have to actually calculate them. You don't have to calculate them. For level 3, you will need to calculate the limits and then do the laws, okay? You'll have to calculate the limits and then do the laws. All right, so let's look at level 2 examples. I'm not going to write down the given that. You guys should have that in front of you. So level 1 says the limit as x approaches a of f of x plus 2 g of x. So in order to do this, in order to use the rules, what I want you to do for full credit is I want you to show you splitting up the thing and computing it. So I'm going to split it up. I have the limit as x approaches a of f of x plus 2 times the limit as x approaches a of g of x. Yes, this 2 can come out in front because it is a constant that you'll multiply by, okay? The 2 can come out in front. Any coefficients can come out in front of that limit. Okay, so now let's look at our example. What does it tell me that the limit of f of x is? Do we not know where I'm getting this from? Okay, so we're looking at this example here. This is where we're looking, okay? This is where we're looking. What is the limit of f of x? 2. What is the limit of f of x? It's 2. So where this is, I'm going to put 2. Okay? What is the limit of g of x? What is the limit of g of x? Look on look on the paper. What's the limit of g of x? Not 2. -4. What's that? You okay? Post it? Yeah. Okay. So now you just simplify. 2 plus -8 is -6. Okay? It's just arithmetic with limits. Okay? Arithmetic with limits. That's it. That's all we're doing. Questions? Are you sure? All right, number 2 then. Yeah. Yeah. We have the limit as x approach. Can you see this color? No? Okay. H of x minus 3 g of x plus 1. I'm sorry?
Do you want or do I put it?
Put it back over there. Unless it's not turning on or working. So we need to split it up. The limit as x approaches a of h of x. What will go next? What symbol? What arithmetic sign? No. What operation? There you go. What operation comes next? So if we have this, what's going to be next? Subtraction. The limit as x approaches a. Oops, sorry. What should go in front of this? Thank you, Estrella. That was Estrella, right? Do you still have my money? No, here it is. I'm just writing it better. Plus the limit as x approaches a of 1. So you'll see us combining level 1. You'll see us combining level 1 and level 2 and 3. Okay, when you get to 2 and 3, you will also combine level 1. So this is the constant rule. Okay, so what is the limit as x approaches a of h of x? I heard somebody whisper it. Look at your paper. Not 3. Unless I wrote it wrong. What is the limit at x approaches a of h of x? 0. Is anybody confused so far? Because we're not... Are we good? No? Yes? I can't help you. We cannot help you if you're not talking. Okay, we're just going to keep going then. 0 minus... What is the limit of g of x? -4 plus, what is the limit as x approaches a of 1? Look at level 1 if you're confused. Yeah, 1. I see some of you holding up the one finger. Yes, just say it. Just say it, please. And that's going to be equal to 13 if I did my math in my head correctly.
What's another one?
Good question. Thank you for asking. G of x is -4. Do you see that? Sure? Estrella?
Yeah.
Okay. Yeah.
Where did you get the one from?
Where did you get the 1 from? So this goes back to level 1 rules. If I can find them. So level 1 rules say that if I have the limit as x approaches a constant, it's just that constant. So remember, a constant is a number without a variable. This is a number without a variable, so this comes down. Okay? That makes sense? Sure? Okay. Good questions. Good questions. Thank you. Questions. Yay! Are we good? No? Okay. All right. Next one. We have the limit as x approaches a of f of x times g of x. So I'm going to split it up. Miss Santana, do I have to do this for all of them? Yes, and I will tell you why. When we get to more rigorous, more in-depth problems, it will be easier for you to split up the limits and find them separately than to try to do it all together, okay? Limit as x approaches a of g of x. So this is the multiplication rule. I have two limits. They're both approaching the same value, so I'm going to separate them. Okay, so what is the limit as x approaches a of f of x? So we're using those three things for all of the 6 problems. I heard somebody whisper it. Anybody? How about we hold the fingers down? Yes, 2. Any questions on where I got that from? Okay, what's the limit of g of x then? 4, not 4. -4. So now I'm just going to simplify that, and the answer is -8. Questions? 10 minutes, 10 minutes. Questions? Pretty straightforward? Yeah. Okay, number 4. Going too fast, slow, just right? I'm not paying attention. I'm falling asleep. I'm working on English. All right, number 4 says the limit as x approaches a of g of x quantity squared. Now I don't have a rule for this, but what do we think we're going to do to the whole limit? What do we think we're going to do to the whole limit? What are we going to do to it? Square it. So what is the limit as x approaches g of x? What is this limit? What did our list tell us this limit is? -4. Yes, -4. -4. That's going to be equal to 16. All right, seniors. I'll wait until you're done writing this down because I need you to listen, because I know you're going to get this wrong if you're not listening. We have a calculator because, no shade, but just a tiny bit of shade. We rely on our calculator too much, and not just you guys, just like this generation in general relies on a calculator too much and can't do math facts. Okay? No shade, a little bit of shade though. We have a calculator. It's a great tool to use, but we need to know how to use it. Okay? When you're typing this in, don't write this down. What I'm about to write down underneath this last example, don't write down. Okay? A lot of you, what you type into your calculator is -4 squared. Okay? I want you all to type that in exactly like that. Exactly. Exactly. Do we get -16? Yeah, because your calculator does order of operations. And what comes before? What is the first thing we do? What is the first thing? Huh? No. Like, in order of operations. Please excuse my dear Anna Santana. Parentheses. Do we have parentheses? No. What's next? Exponents. Do we have an exponent? Yeah. So your calculator is doing 4 squared, which is 16. Then it has a -1 that it's multiplying by. Okay? This is not the same as this. This is not the same as this. Okay? Now use parentheses to put the negative in the use parentheses now to put this. Do parentheses, -4, parentheses, square. And I bet you get 16. Right? They're not the same thing. Make sure you're using parentheses. Because mathematically, this is -4 times -4. What is a negative times a negative? Positive. And then what's 4 times 4? 16. This is why they're not the same. So please, in all that is holy or whatever your religious affiliation is, please use parentheses. Okay? All right. We're not going to be able to get through all of these, so we'll finish up the examples and your practice tomorrow. Tomorrow's Thursday? We'll have a 4-question exit ticket tomorrow. No, sorry. 2, 4, 6. 6 questions. 2 for each level. Cool? Put the calculators away. Poor favor.